All right, here's a video on topic 4.6 for AP Calculus. The topic here is approximating functions with tangent lines, which is a topic that we've covered before, but we're just going to take it one more tiny step further. So there's three big ideas here. We are going to review and remember how to write an equation of a tangent line to a given function. We want to understand the concept of the tangent line to a function, but then use those tangent lines to approximate a function value near the point of tangency. So we have to remember that a tangent line is just like a line, and to write an equation of a line, we need a point and a slope. These steps are put in here just to refresh your memory on how to write an equation of a tangent line. I'm not going to read through them. Feel free to pause the video if you'd like to review them on your own. So example 1, we are given an equation f of x equals 3e to the 2x plus 5. We want to write an equation of the line tangent to f of x at x equals 0. So what we first want to do is find the point, and that's going to be given to us by substituting in 0 into the original function, okay? And so if we put 0 into the original function, we get 3e to the 2 times 0 plus 5. E to the 0 is, of course, just 3, and so overall we get 8. And so our point is 0, 8. Pretty straightforward. Then to find the slope, I'll reveal everything here. We first have to find the derivative, but don't forget to use the chain rule here. So when we find the derivative of 3e to the 2x, we have to multiply that by 2. We can simplify that to 6 times e to the 2x. Then you can substitute in 0. Notice my notation here. I'm using correct notation to indicate that I'm finding the general derivative and then the derivative at 0. And that gets me a slope of 6. Now I can take my point 0.8 and my slope of 6, and I can write my tangent line equation. TLE is an abbreviation for tangent line equation. Because we have a 0 here, feel free to rewrite it in slope-intercept form, taking that 0 part away. All right, so that should have been a very quick review of how to write a tangent line equation, which I feel like we've done plenty of. Let's move on to example 2. This one's a little different only because t is your independent variable and y is your independent variable, but then they're giving us a point in terms of t comma y. So it's just a little different in terms of the variables. The derivative of the function y equals k of t is given by dy dt, which is 1/4 times y plus 5. I'm pointing out, notice that that's y, where usually we're used to that being t or x. It is known that k of t equals 19. Well, here they're giving us that y equals k of t, so that means that 3 must be t and 19 must be y. So let's go ahead and find my point. The point is given to us as k of 3 equals 19, so we can write that as 3, 19. Now, to find the slope, they give us the slope as dy dt, but we want to evaluate that slope. Make sure you're using correct notation here at the point that we found, t equals 3. Let me just put 3, 19. So that looks like 1/4 times. Now be careful not to put 3 in for y. The y value is 19, so we put 19 in for y. And that gets us 24/4, which is 6. And now we can write our tangent line equation to be y equals our slope 6 times x minus, t minus 3 plus 19. All right, so that's a big review on writing tangent lines, but here's kind of the why behind everything. What's the point? We've been doing that since unit 1 or 2 when we first saw that. So why do we even want to write equations of tangent lines? Well, the nice thing is that tangent lines can help us approximate values of a function when we can't easily evaluate the function. Sometimes functions are too hard to evaluate. So notice there's a function over here, f of x, and the tangent line t of x to the right. At the value x equals 5, the tangent line t of x has the same y value as f of x. at values near 5, the tangent line is near the graph of f of x. This allows us to use t of x to approximate f of x near x equals 5. For example, if I wanted to find the value of f of 5.1, but I don't have an equation for f, I can find the tangent line, and it's going to be close enough. It's going to be extremely close. Might not be exact, but it's going to be very, very close. So that's why we need tangent lines. All right, let's move to the next page. Example 3, I feel like you could do completely on your own, which is why I just went ahead and filled it in. It says the functions f and g are differentiable with selected values of f, g, f prime, and g prime given above. Then they tell us let h of x equals f of g of x. Part A says write an equation of the line tangent to h of x at x equals 4. So this is pretty straightforward. We've done this many times. Your point is going to be by plugging in 4. So h of 4 is f of g of 4. Now you have to find g of 4 from the table right here, and you plug that in. Now you have to find f of 5. F of 5 is right here, which is -9. So my point is 4, -9. My slope would be h prime of 4. This requires the chain rule. So you would do the derivative of the outside function, which is f prime, times the inner, or not times, but of the inner function at 4, then times the derivative of the inner function g prime of 4. Now, we have to figure out what is g of 4 right here. G of 4 is 5, so I went ahead and put in 5 here. G prime of 4 is down here at -2, so I put that there. Now the last thing I have to use my table to find f prime of 5. F prime of 5 is right here, 3, so I have 3 times -2, which is -6. That's my slope. So my tangent line equation is h of x equals -6 times x minus 4 minus 9. Now I'm going to use that to help me approximate h of 4.1. Given this table and knowing what h represents, I have no way of figuring out what is h of 4.1. I don't have an equation, and I have no values based on h. So I can use my tangent line equation. Now that we have the tangent line equation, we just take our equation and put 4.1 in for x. So by putting in 4.1 for x, simplify it, multiply, subtract, we get -9.6 for the approximate value of h of 4.1. All right, next example. Let y equals f of x be the function with this as the derivative, and it contains the point 1, -5. Write an equation for the line tangent to the graph at x equals 1. Use your equation to approximate f of 0.8. I'd like you to try this one on your own. Perhaps pause the video, give it a shot, and then I'll reveal the answer. All right, so my point was given to me, 1, -5. My derivative was given to me, but I have to evaluate it at that point. So I substitute in the appropriate values, 1 for x, -5 for y. Simplify, and I get my slope is 3. So my tangent line equation is f of x equals 3 times x minus 1 minus 5. Now to approximate f of 0.8, I put 0.8 in for there, and I get -5.6 for my approximation of f of 0.8. All right, the last question is very similar to what you could see on an AP test. As opposed to just sort of giving you equations, it'll be more of a word problem situation. On Thanksgiving, a delicious pumpkin pie removed from an oven has a temperature of 175 degrees Fahrenheit. The temperature of the pie at time t minutes can be modeled by the function where here's the derivative. Use the tangent line to p at t equals 0 to approximate the temperature of the pie 4 minutes after being removed from the oven. So let's first find our point. Remember, we're looking at it at t equals 0. So what we want to do is think about, well, what would the temperature of the pie be at time 0? We were given that right here. At time 0, our temperature is 175, so I can say that my point is 0, 175. Now, to be able to find the slope at 0, we just simply plug in the point 0, 175 into the derivative function. So you're putting 175 in for P, that's your temperature. And if you simplify that, you get -3 for your slope. So now I can write my tangent line equation, put my -3 in for my slope, times T minus 0 plus 175 using the point up above. If you want to take away the -0, you can. You don't really need that. But then at this point, we want to approximate P of 4, which is 4 minutes after the pie comes out of the oven. So we put 4 in for T, multiply those together, add the 175, and we get that the temperature of the pie is 163 degrees Fahrenheit. All right, so that is the end of the 4.6 video lesson. A summary of writing tangent line equations and approximating function values.